Hello Flight Simmers and welcome back to Alpha Hotel Flight Simulator Training. In this video we'll take a look at instrument and system failures that you can encounter in a glass cockpit like the Garmin G1000 when flying IFR. We'll take a look at what types of failures can happen, what they look like, how to deal with them, and then what failures can be replicated in Microsoft Flight Simulator. Spoiler alert, with the Garmin G1000 and the Cessna 172 there aren't too many failures you can replicate in the sim. As always, if you enjoy the video, don't forget to like it, share with your friends, subscribe to the channel, and ring the notification bell to be alerted to new content. One of the areas of operations required to be tested on a real-world instrument check ride is flying an approach with a loss of primary instrument indicators. So on a real-world check ride, one of the approaches you'll have to fly during the test will be a non-precision approach with some of your instruments not working. In the previous video, we looked at what types of failures you can encounter in an airplane with an analog instrument panel, how to safely handle those failures, and how to replicate some of them in Flight Simulator. I'll leave a link to that video in this video's description if you want to check it out. With the advent of glass cockpits in general aviation, instrument flying with a loss of primary instruments or partial panel looks quite a bit different than it does with an old steam gauge panel. For starters, digital instruments and their respective systems are more reliable and less prone to failure than their analog counterparts. In addition, there is more redundancy built into instrument systems in many glass cockpits, in addition to secondary or backup primary flight instruments. I'll mention that we'll primarily be talking about failures that can occur with the G1000 NXI installation in the Cessna 172. So if you're not familiar with that piece of equipment, I'll leave a link to my video series on the G1000 in this video's description. That being said, much of what we'll talk about today will be applicable to all G1000 installations, and much of it will be applicable to all types of glass cockpits. So what can fail on the G1000 panel? The failures you can get in this airplane include a single display unit failure, such as the PFD or MFD failing, an alternator failure, which will affect the instruments available to you over time, an avionics bus failure, a single instrument failure, such as losing the attitude indicator or airspeed indicator, and systems failures like a pitot tube blockage, a static port blockage, an air data computer failure, and an AHRS failure. Of these failures, the only ones we can replicate in Flight Sim 2020 are the display unit failures, which we have to do as part of an avionics bus fail, and that will only fail display unit 2, an alternator failure, and as I mentioned previously, an avionics bus 2 failure. We can't replicate or cause any other failures currently in Flight Sim 2020, even with third-party mods, at least not that I'm aware of. While there are mods out there that let you fail instruments, the only ones I've found work on analog instruments and not digital ones. But if you know of a way to create a failure that I've not covered in this video, please let me know in the comments section. The G1000 NXI system components that are visible to the pilot include 2 display units and an audio control panel. Display unit 1 on the left is configured as a primary flight display, and display unit 2 on the right is configured as a multifunction display. System components that are not visible to the pilot include an air data, attitude, heading, and reference system, or AD/AHRS, an attitude, heading, and reference system, a air data computer, an engine and airframe unit, a magnetometer, and dual integrated avionics units, which contain 2 VHF comms, 2 GPSs, 2 VOR ILS receivers, an ADF, and 2 flight directors. And the system also contains a Mode S transponder. The magnetometer feeds its data, heading data, to the AD/AHRS and the AHRS, and then the rest of the components feed their data to the dual integrated avionics units, which then create images to display on the 2 display units. So taking a look at these components individually and talking about what they do, the attitude, heading, and reference system, or AHRS, is what has tilt sensors and accelerometers in it. Basically, it replaces your gyroscopes for determining attitude information, and then the magnetometer is basically a fancy magnetic compass that provides heading information to this unit. So this system is what's providing the system with all of its attitude and heading information. And then the air data computer is what receives the data from the pitot-static system and feeds the system its airspeed, vertical speed, and altitude data. The engine and airframe unit compiles data or collects data on aircraft systems. For the Cessna 172, it's primarily your engine-related systems, so fuel flow, oil pressure, oil temperature, exhaust gas temperature, vacuum pressure, fuel quantity, those sorts of things, electrical system status. That's where you get all of that information from. It also has, I believe, a temperature sensor in there as well that allows the system to calculate true airspeed. And of course, the Mode S transponder provides more data than a typical transponder and feeds that into the system as well. And then you'll notice that we also have an AD AHRS, which is a combined air data computer and AHRS, so it's getting both pitot-static information and attitude and heading information all in one system. And because the system is designed like this, we basically have dual AHRS and dual air data computers. If one of these systems fails, we still have a redundant second system. So having an AHRS failure or an air data computer failure on this system is not that big of a deal if you just lose the one system because you have a redundant system. The system will notify you that one of the systems has failed, but you will still continue to get accurate data for heading, attitude, airspeed, altitude, vertical speed because the other system is still providing it. The role of the dual integrated avionics units, in addition to containing all of this equipment that we see here, is to collect the data from the other components, combine it together, and put it up into information that we can use up here on our display units and provide a way to interface with the system. In the Cessna 172 that's equipped with the G1000 panel, we do have 3 analog standby instruments or backup instruments that are located underneath the panel, underneath the display units. We have an airspeed indicator, and we have an attitude indicator and an altimeter. The airspeed indicator and the altimeter are analog pitot-static instruments. They get air directly from the pitot-static system, and they have no input from the air data computer whatsoever. They are completely analog instruments with no electrical parts whatsoever except for the lights that light them, and they're again getting air directly from the pitot-static system, inflating the diaphragm on the airspeed indicator and moving the aneroid wafers in the altimeter. So if the entire electrical system fails, these instruments will still work. The gyroscopic instrument, the attitude indicator, the gyroscope is spun by the air from the vacuum pump. That's actually the only thing that the vacuum system does on the Cessna 172 with the G1000 panel is provide the air to spin this instrument. So if you lose the vacuum system, this is the only instrument that you will lose. And again, since that is attached to the engine, even if you lose all electrics, you'll still have this instrument even with no power. The vacuum pump will still run and you'll still have that attitude indicator. Let's talk about single instrument failures first. Just like with an analog panel, you can have a single instrument go inoperative. In the G1000, if a single instrument fails, or for that matter, if any component displayed on a display unit fails, the data field for that instrument or that component will be removed and replaced with a bright red X on a dark red background. And similar symbology is used for most glass cockpits. You get a little preview of what this looks like for the airspeed indicator, altimeter, VSI, heading field, and radios while the G1000 is going through its boot up cycle when you first power it on. The solution to dealing with a single instrument failure on a glass panel is the same as if a failure occurred on an analog panel. You compensate with your remaining instruments, and most glass cockpits have a backup primary set of primary instruments like the analog instruments we have in the 172. If you want to go through the full briefing on how to handle each type of single instrument failure, again, there's a link to that video in this video's description. Unfortunately, these are not failures that can currently be replicated in Microsoft Flight Simulator, even with a third-party random failure utility. It just fails the analog instruments and systems and not the digital ones. You can also have a pitot tube or static port blockage on the G1000 that will affect your airspeed indicator and your altimeter or VSI. Like a single instrument failure, the causes, symptoms, and solutions are the same if they occur on a digital panel as they are if they occur on an analog panel. So you can refer to the video on analog system failures to learn how to deal with those as well. I do want to mention that, just like on the analog 172, there is an alternate static source inside the cabin of the G1000 172. The knob to activate it looks like the same as it does on the 172 Classic. It's a red knob that it's located to the left of the throttle on the G1000 panel. Just pull it out to switch to the alternate static source if you think you have an exterior static port blockage. The air data computer and AHRS, or the AD AHRS, can also fail in the G1000, though again, in the G1000 NXI, since you have redundancies for both of these systems, it's unlikely that the primary and the backup would fail simultaneously. Since we have an AD AHRS and an AHRS and an air data computer, it's unlikely that you would lose two of these components at once, thus leaving you without either AHRS data or air data computer data. But let's take a look at what those failures would look like if they did occur. If the air data computer fails, you will get a loss of PFD airspeed indication, a loss of your PFD altimeter, and a loss of your PFD VSI. It would look like a single instrument failure on all three of these instruments. You would get the red X with the loss of the data field and the dark red background. The solution to this failure is to utilize those analog or backup altimeters. The analog or backup altimeter and the backup airspeed indicator for your altitude and airspeed information, and then you just have to kind of guesstimate what your rate of descent is based on what your altimeter is doing. If the if the AHRS fails, you're going to lose your PFD attitude indicator, and then you're going to lose your heading on your HSI indication. So the compass rose will not turn anymore. It will still be up there, and then the heading field will go blank. It'll have a red X in it. So the way you compensate for this is to utilize your analog or backup attitude indicator for your attitude information, and then use your compass and your MFD GPS ground track, which is a field that's typically up there, and use those two, combination of those two, to see what your heading is. You'll also have to compensate a little bit. You will not lose your navigation data from the HSI, but again, the heading on the HSI will be incorrect, so it may not be pointing in the direction that you expect it to point, so you will have to compensate for that. Unfortunately, again, this is not a failure that we can currently replicate in Microsoft Flight Simulator. So let's take a look at some failures that we can replicate in Microsoft Flight Simulator. The first one that we can replicate is an Avionics Bus number 2 failure. And the way that we emulate that failure is by simply using the Bus 2 side of the Avionics master switch. We just turn that off, and that will create a failure on Avionics Bus number 2. If we lose Avionics Bus number 2, we're going to lose our right display unit or our multifunction display, our transponder, although I'm not sure this is emulating correctly right now in Flight Simulator, nav radio number 2, comm radio number 2, and the audio control panel. So if we have switched over to comm radio number 2, we're not going to be able to talk to anybody. So it's a good idea to keep your comm radios in comm radio number 1 and just use comm radio number 2 to listen into ATISs and things like that. And then we will also lose the autopilot. When you use lose a display unit on the G1000, the remaining display automatically goes into what's called reversionary mode. This mode consolidates the flight instruments and engine instruments on the operative display. If the system fails to go into reversionary mode, you can use this red display backup button at the bottom of the audio control panel. But there's currently not a situation in Microsoft Flight Simulator where automatic reversion won't work. And if you press the display backup button when the displays are displaying normally, it will not do anything. It'll stay in the normal mode. So there's really no reason you would need to use this button in Microsoft Flight Simulator. You'll also have use of the flight directors, but only if the flight director was already on prior to the failure of the bus or the simulated failure of the bus. If you try to bring up the flight director after you switch off the bus, it won't come up for you. And I don't know if this is the way that it normally works. It seems like it would not be. It seems like this is emulated incorrectly. It seems like either the flight director wouldn't come up at all, or you would be able to bring it up if it is still functioning. And then another quirk of Flight Simulator is that you could control the flight director using the autopilot control buttons, and you can use them using the control buttons on either the primary flight display or multifunction display, even when you have Avionics Bus number 2 powered down. And I don't think that would be the case in real life because you're not actually getting any power to the display unit, so the buttons on it shouldn't work at all if you have an Avionics Bus number 2 failure. So let's hop in the airplane and let's take a look at what this would look like in flight. All right, so we are level in cruise flight on a flight from Pine Bluff to Muscle Shoals, Alabama. Identifier there is Kilo Mike Sierra Lima. And we are going to simulate a failure of the Avionics Bus number 2 by turning off the Avionics Bus number 2 switch. And we are, as you can see, tracking the GPS course on the autopilot and holding an altitude of 5,000 feet. So go ahead and simulate that failure with Avionics Bus switch number 2, and we'll see what that looks like. So you can see when I do that, the autopilot automatically kicks off. We lose nav 2 and com 2. We lose our multifunction display over here, and then everything consolidates over to our primary flight display. So we lose our moving map, and then our engine gauges come over here to the left-hand column and push the EFIS display over to the right here just a little bit. As you can see, we still have our flight director, and I believe that still works. I'll put it in heading mode here, and I'm hand flying. I'll go ahead and turn the heading button. You see when I do that, it turns it over to the left there. I can recenter on the heading there, and I can re-engage nav mode. So that all works. Other things that we lose, we're supposed to lose the transponder. It looks like it's still working, so that's not emulated correctly. We did lose our right multifunction display. We did lose our we still have the transponder, which we shouldn't. We lost nav radio number 2 and com number 2. Supposedly, yep, we did lose control of the audio control panel. You can see none of the buttons up here are working right now. So that is no longer functional. And then we did lose the autopilot. So that's not functioning anymore either. If you do want a moving map back, you can go to the map HSI option over here to the soft key and push that. And let's see here, am I doing that right? Yes, there we go. So we push that map HSI key, we go to layout, and we can either put it on the HSI. So there's our moving map on the HSI, and we can zoom out there. There you can see. So we've got a little moving map there back, and that actually turns the HSI into a little bit of an arc, or we can turn it into the inset map so that we have a square moving map over here. And again, the range controller on a primary display is going to control the range zoom for that. We also have access to all of the GPS functions. I'll go ahead and turn the map off here by using the GPS controls over on the right-hand side here. So we can go into flight plan and we can edit our flight plan. The layout here is a little bit smaller than it is in your multifunction display, but we still have use of the flight plan. And we can go in here to procedures and we can select approaches and activate approaches because we might, this would be considered emergency. We might want to make a divert. We might want to return to Pine Bluff. So we can do all of those and use the GPS still to navigate. We can also, I'll put it back in heading mode here. We can also use the CDI button just like we would in normal flight. With everything working, we can go between the different navigation sources on the CDI. So that is what a failure of the number 2 avionics bus looks like. The other common failure that you'll get on check rides is a failure of your left display unit, and they can do this, I believe, by actually pulling the circuit breaker for the display unit and making it go blank. And usually what they'll tell you, I'm going to switch Avionics Bus 2 back on here real quick, and we'll talk about what that looks like. What will happen is your PFD will go blank, and your MFD will be what's left. And a lot of times they will say it didn't consolidate, and they will make you fly it, without the screens consolidating, or they'll just cover this screen up with a some sort of a instrument cover, except for possibly the HSI navigation source area. So what you'll have to do is use your backup attitude indicator to fly, your backup airspeed indicator, your backup altimeter, and then you can use the track from the moving map up here from the multifunction display. And generally, they'll probably have you fly a GPS approach, but they could have you switch over and fly a VOR approach if they give you the navigation needle on the HSI. The HSI itself, the heading portion won't work, but the needle will still work. Unfortunately, even though that's probably the most common failure you'll get on a G1000 type panel on a check ride, unfortunately, it's not something we can emulate in Flight Simulator. Now let's talk about what an electrical failure in the G1000 equipped Cessna 172 looks like and what impact it will have on your instruments and systems. There are 3 sources of electrical power on the G1000 equipped Cessna 172. The alternator, which provides electrical power to all systems when it's on and the engine's running, and charges the main battery. The main battery, which provides power for engine start and to all systems in the event of an alternator failure or if the alternator is turned off. This battery will last about 30 minutes if electrical load is sufficiently managed. In other words, if you turn off electrical things that you don't need if the alternator is not working. And then finally, we have the standby battery. This is the battery that we have the little red switch for up here. We test it and then turn it to arm when we start the engine. If it is in the arm position, it will automatically provide power to the essential bus for approximately 30 minutes after the depletion of the main battery. And the components that are on the essential bus include the primary flight display, the air data computer, the AHRS, the nav and comm radios number 1, the engine instruments, and the standby instrument lights. So standby instruments don't require any electrical power, but they do have lights that shine on them that need electrical power. Notable systems that will not function if you're running off the standby battery include the autopilot and the flaps. You won't have any way to turn your autopilot on, and the flaps will not come down if you're running that standby battery. So let's jump into the airplane and let's look at what an electrical failure in flight would look like. So the other failure we'll look at is the failure of the alternator and how that works. First, before we do that, I'm going to point out that over here on the multifunction display and on the primary flight display, when it gets consolidated, you do have an electrical system display on your main engine and systems pages here. It shows you the bolt status of both the main battery and the emergency battery. Right now they're both showing 28 volts because they're hooked up to the alternator. And then they will show whether they're charging or discharging. Right now they have a positive 8 amps, so they are charging. But if you start to see a negative over there, then you know that they are no longer charging. So let's simulate a failure of the alternator by turning the alternator off. And you can see that all that changes when that happens is you get the low volts warning. And we'll hit the warning tab soft key down there to get that alarm to silence. And you can see now this has gone back. The main battery's gone to 24.4 volts. and it shows a discharge of negative 33 amps. So our procedure is to turn off everything we don't need. So I'm going to go ahead and I'm going to turn off the nav lights. It's an emergency. You can see the discharge goes down a little bit. I'm going to turn off the beacon, and it goes down a little bit more. Well, it won't let me turn the beacon off for some reason, but I would. If I'm not in icing conditions, I can turn that pitot heat off, and you can see the discharge drops a little more, but we are starting to lose voltages already. It was 24.4, now it's 24.3. So we should have, if we manage our electrical load appropriately, about 30 minutes, but as of right now, we still have our autopilot, we still have both screens, we still have all of the radios, all that sort of stuff is still working for us. So we still have a full set of instruments. We do need to declare an emergency, and we do need to get on the ground, but at this point we still have most of our instrumentation. Okay, let's say that we've gotten in a situation where we've flown for more than 30 minutes, and now our battery has failed. So we'll go ahead and simulate that by turning the battery switch off, and you can see we lose quite a bit of stuff when we lose that. So we get a caution that tells us we are now on the standby battery. We lose our multifunction display, we lose nav2, we lose com2. The audio panel has gone dark as well, just like with a Avionics Bus number 2 failure. Basically, the only things that we have left are what's on this essential bus right here. And you can tell what's powered on what buses in the 172 by looking at these circuit breakers down here. The only things we have are the crossfeed bus and the essential bus. The essential bus has the primary flight display, the ADC and the AHARS, so the air data computer and AHARS, so we're still getting airspeed and altitude, and heading information and attitude information. We have COM1, we have NAV1, we have the engine instruments, we have the standby indicator lights, so the standby instrument indicator lights, so those will continue to be illuminated. And then we have the standby batteries still powered. And you can see over here, earlier we were discharging the main battery. That is no longer discharging because it has 0 volts because we turned it off or we're simulating a failure. And we have 24.3 volts on the emergency battery, and you can see that is also showing a discharge -6 right now. So that's all we have left at this point, and of course we have the standby instruments that are not electrically powered, but at this point we need to get ourselves on the ground in the next 30 minutes, or if we don't do that and our battery runs out, at that point we are down to these 3 instruments. So we have no navigations, no communications, we do not have any flaps. And actually we don't have any flaps when we go to the standby battery. But at this point, the only thing we can do is either try to descend wings level through the clouds and get under the clouds to try to make an emergency landing, or try to fly until we get into VFR conditions. So not a situation you want to be in. You want to, if you have an indication that you've had an alternator failure, you want to declare an emergency and get on the ground as quickly as you can, so you do it with all the instruments, but at least with the stuff that is on the essential bus. Again, the instrument rating practical test standards require that you fly one approach with loss of primary flight instrument indicators. If you want to practice that in Flight Simulator, probably the best one to do is that the Avionics Bus number 2 fail. And then shoot it with a consolidated screen. Other than having everything on the single screen, you don't shoot the approach any differently than you do when you're flying it with both screens. So if you want to go out and practice that, again, the more realistic failure is probably losing display unit 1 and not being able to consolidate onto the multifunction display. So losing your primary flight display and not being able to consolidate over to the multifunction display. I think that's something you see a lot in check rides, but short of covering up your computer monitor so that it covers up your primary flight display, there's not a way to simulate that in Microsoft Flight Simulator, at least right now. Maybe we'll get a more robust failure system that will allow us to do that in Flight Sim 2024. The standards do not change when you're shooting partial panel approaches. You still have the standards of being able to maintain your altitude plus or minus 100 feet, your selected heading plus or minus 10 degrees, your airspeed plus or minus 10 knots, and then accurately track your radials, courses, and bearings when you're prior to the beginning of the final approach segment, and then on the final approach segment, maintain no more than a 3/4 scale deflection of the CDI and still maintain your airspeed plus or minus 10 knots, and then don't go below the MDA more than 0 feet. You're given 0-foot tolerance, and no more than 100 feet above the MDA. And of course, if you're shooting an approach that has vertical guidance and a decision height, then just fly that to the decision height and then miss the approach. That concludes this video. Hopefully it's given you a good idea of what kind of instrument failures you can experience in the Garmin G1000, how to safely deal with them, and the types of failures you can replicate and practice dealing with in the sim. Again, if you've enjoyed the video, don't forget to hit the like button, share with your friends, subscribe to the channel, and ring the notification bell to be alerted to new content. Thanks for watching, and we'll see you next time.